Imagine waking up on a typical morning. Your alarm rings, and almost without thinking, you reach out to silence it. You stumble to the bathroom, brush your teeth, shower, and before you know it, you are sipping your first cup of coffee. These actions unfold effortlessly, as if you are following a well-rehearsed script. Now, contrast that with a morning when your usual subway line is down. Suddenly, you are checking maps, weighing the pros and cons of taking a bus or an alternative train, calculating which route will make you less late. Your mind feels slower, more effortful, as you puzzle through your options. This everyday scenario captures the essence of a profound insight into how our minds work, a distinction that psychologist Daniel Kahneman, along with his collaborator Amos Tversky, helped crystallize in modern psychology the difference between two kinds of thinking, which Kahneman famously labeled System 1 and System 2. These are not literal parts of the brain, but rather metaphors for the ways we process information and make decisions. System 1 is the fast, automatic, and intuitive side of our mental machinery. It operates outside of conscious awareness most of the time, handling the countless small judgments and actions that guide us through daily life. When you recognize a friend's face in a crowd, solve simple math problems like 2 plus 2, or recoil from a snake-shaped stick on a hiking trail, it is System 1 at work. This system draws on experience, patterns, and even emotion to quickly generate responses, sometimes before we are even aware there is a decision to be made. As research describes, it is responsible for many everyday decisions and the shortcuts, what psychologists call heuristics, that allow us to function efficiently in a complicated world. System 2, in contrast, is the slower, more deliberate, and analytical mode of thought. When you are confronted with a new or unfamiliar situation, like figuring out an alternative route to work when your usual commute is disrupted, System 2 steps in. It is the part of your mind that reasons through problems, weighs evidence, and considers possibilities in a conscious, orderly fashion. System 2 thinking is required for tasks that demand attention, such as solving complex math problems, planning a vacation, or learning a new skill. While System 1 might leap to a conclusion, System 2 is the mental supervisor, checking the work, analyzing, and, when necessary, overriding the fast responses of its counterpart. The distinction between these two systems is foundational in the field of cognitive psychology. Dual process theory, as it is called, has a long history, with roots that trace back to philosophers like Spinoza and William James, who reflected on different types of mental operations. But it was Kahneman and Tversky who gave these ideas their modern shape, using the language of thinking, fast and slow, to illuminate the human mind's architecture. This model has had a transformative impact, not only on psychology but also in economics, education, and even clinical practice, as scholars and practitioners alike recognize how much of our behavior is governed by the interplay between fast, intuitive responses and slow, reasoned deliberation. One of the most striking features of System 1 is its speed. It can process vast amounts of information almost instantaneously, drawing on learned patterns and experiences to generate complex ideas without conscious effort. This automaticity allows us to navigate the world efficiently, catching a ball, reading a familiar word, or reacting to a sudden sound without stopping to think. System 1 is emotional, instinctive, and always ready to jump to conclusions, which is both a strength and a weakness. Its reliance on shortcuts and patterns means it is prone to mistakes, especially in situations that are new or ambiguous. For example, it can mislead us with optical illusions or cognitive biases, systematic errors in thinking that can affect our judgments and decisions. System 2, by contrast, is inherently effortful. It requires attention and energy, and because of this, we tend to use it sparingly. When System 2 is engaged, we are more likely to check our impulses, question our assumptions, and apply logic to solve problems. It takes charge when we encounter something that does not fit our expectations, or when the stakes are high and accuracy matters. If you have ever tried to memorize a long number, analyze a complex argument, or learn a new language, you have felt the strain of System 2 in action. Unlike the automatic leaps of System 1, System 2 moves in careful, deliberate steps, constructing thoughts in a methodical manner. Despite their differences, these two systems do not operate in isolation. Instead, they work together, with System 1 handling most of the routine work and System 2 monitoring in the background, ready to intervene when something unusual or challenging arises. In a sense, System 1 is in charge, most of the time propelling us through our days with little conscious effort. System 2 acts as a supervisor, stepping in when careful thought is needed, but it is easily fatigued and prone to accepting the suggestions of System 1 when under pressure or distracted. Understanding this dual system architecture is crucial for anyone interested in human cognition and decision-making. Much of what makes us human, our creativity, our errors, our flashes of insight, and moments of confusion, can be traced back to the dynamic between these two systems. For example, the same mental shortcuts that help us make quick decisions can also lead us astray, producing biases that affect everything from financial choices to moral judgments. Recognizing when we are relying too much on System 1 and when to engage the careful scrutiny of System 2 is a vital skill in an increasingly complex world. The influence of Kahneman's work extends well beyond academic psychology. His book, Thinking, Fast and Slow, brought the language of System 1 and System 2 into popular conversation, shaping how we talk about rational and non-rational motivations, cognitive biases, and the very nature of thought itself. The dual process model has provided new tools for educators, helping them understand how students learn and why certain teaching methods succeed or fail. It has had an impact in economics, where recognizing the limits of rational decision-making has led to new theories about markets and behavior. And, in clinical psychology, understanding the mechanisms of fast and slow thinking has informed treatments for various conditions, including anxiety disorders and addiction. Of course, the science is not settled. There are ongoing debates about the unity and mechanisms underlying these systems, about whether the distinction is as clear-cut as the metaphors suggest, or whether the mind's architecture is more fluid and interconnected. Some theorists argue that the categories of fast and slow thinking are too simplistic, and that real-world cognition often involves a complex blend of intuition and reflection. But what is clear, from decades of research and observation, is that the dual process model provides a powerful framework for making sense of the mind's intricate workings. As you listen and reflect on these ideas, consider your own experiences. How often do you find yourself acting on instinct, relying on gut feelings or habitual responses? When do you slow down, pause, and think things through? The dance between System 1 and System 2 shapes our perceptions, our decisions, and ultimately, our lives. By becoming more aware of these two systems, we can begin to recognize the sources of our strengths and our biases, and perhaps learn to harness the full potential of our remarkable, multifaceted minds. Imagine standing in a crowded room, the hum of conversation swirling around you. Out of the corner of your eye, you notice someone whose expression is unmistakably angry. Even before you consciously register who they are or what might have provoked them, your mind reacts. Your heart rate quickens, your body tenses, and a subtle urge to avoid the person flickers in your chest. This split-second, effortless recognition of emotion so fundamental to social life offers a glimpse into the workings of what Daniel Kahneman calls System 1 thinking. System 1 is always active, an invisible partner in the business of living. It operates with astonishing speed and little conscious effort, like a behind-the-scenes director orchestrating countless judgments and actions. When you read a stop sign without thinking, reach for your house keys on a familiar hook, or sense that someone is watching you, it is System 1 springing into action. It is automatic and involuntary, a mental reflex shaped by biology and years of experience. This part of your mind allows you to instantly grasp the meaning of a familiar face or the emotional tone in someone's voice, long before you could put your reaction into words. One of System 1's great strengths lies in its use of heuristics, mental shortcuts that simplify the complexity of the world. Faced with a flood of information, System 1 relies on patterns, associations, and gut feelings to guide action. If you have ever found yourself reaching for the same brand of cereal at the grocery store, barely glancing at the alternatives, you have witnessed System 1 at work. It is the reason brand loyalty can seem almost irrational. Why, after a change in packaging, some customers suddenly feel uncertain about whether their favorite juice is still the same. When Tropicana redesigned its packaging, for example, many consumers instinctively rejected the new look, their automatic associations with the old familiar packaging disrupted. Such reactions highlight System 1's role as the stubborn guardian of everyday decision-making, quick to protect established patterns and wary of the unfamiliar. This intuitive thinking is not just about reacting to routine choices or familiar faces. System 1 is creative and adaptive, mapping new experiences onto existing knowledge structures. When confronted with a novel situation, System 1 scans its vast web of associations, searching for something that feels similar. This process is context-sensitive. An emotional advertisement might remind you of a childhood memory, prompting a feeling of trust or nostalgia toward a brand. System 1's judgments often feel self-evidently true. There is little room for doubt or analysis. The answer simply appears, as if from nowhere. Yet the gifts of System 1 come with certain limitations. The very features that make it so effective at handling the ordinary can make it vulnerable to error, especially when the world presents something unexpected or ambiguous. System 1's guiding principle is often what you see is all there is. It draws on the information most readily available, building a coherent story from whatever comes to mind first. This tendency toward coherence, while useful for quick decisions, can sometimes lead us astray. Consider, for example, the phenomenon of confirmation bias. System 1 is predisposed to favor information that fits with existing beliefs, ignoring or downplaying evidence to the contrary. It does not deliberately distort the truth. Rather, it rapidly assembles a mental picture that feels complete and convincing, even if it is incomplete or inaccurate. Similarly, the availability heuristic, the tendency to judge the frequency or likelihood of an event by how easily examples come to mind, emerges from System 1's reliance on associative memory. If recent news stories have highlighted airline accidents, System 1 may overestimate the dangers of flying, simply because those images are vivid and easily recalled. These cognitive biases are not quirks of a broken mind. They are the byproducts of a system designed to process overwhelming information efficiently. In a world that bombards us with choices, System 1 acts as a filter, drawing on habits, emotions, and familiar patterns to keep life moving. This filtering explains why so many decisions, from what to eat for breakfast to which route to take home, occur beneath the surface, swiftly and effortlessly. System 1's judgments are often emotional, shaped by feelings of loss aversion or a desire for consistency. The prospect of losing something tends to loom larger in the mind than the prospect of gaining, a bias that can steer everyday choices in subtle but powerful ways. For marketers and designers, understanding the sway of System 1 is crucial. When someone walks into a store, their eyes dart among thousands of products. Rarely do they pause to analyze each option in depth. Instead, System 1 seizes on intuitive cues, a familiar logo, an appealing color, the comforting shape of a package. These cues trigger a cascade of associations, steering decisions before the shopper is even aware. The importance of these cues was underscored when well-known brands altered their packaging and found that consumers, disoriented by the change, hesitated or switched products. What might seem like a trivial design tweak to a company can disrupt the automatic, associative processes that guide so many purchasing decisions. System 1's dominance is not confined to shopping or split-second judgments. It governs the rhythm of daily life, handling the mundane and the routine with little need for conscious oversight. Brushing your teeth, tying your shoes, or driving a familiar route to work, all are managed by this relentless, efficient system. Its influence is so pervasive that we rarely notice its presence, except when it makes a mistake. In those moments, we are reminded that the very qualities that make System 1 such a reliable guide, its speed, its reliance on patterns, its emotional undertones, also make it prone to systematic errors. At times, System 1's judgments can be creative. It adapts to new situations by mapping unfamiliar stimuli onto existing categories, blending past experience with present context. This creative adaptability is why people can make sense of a novel object or an unexpected event without conscious deliberation. System 1's responses are not random. They are shaped by both biology and the accumulation of lived experience. Over time, the system becomes finely tuned to the regularities of an individual's world, making it a powerful engine for learning and adaptation. However, there are boundaries to what System 1 can accomplish. It excels at rapid, intuitive responses, but falters when confronted with abstract or hypothetical reasoning. When the situation demands careful analysis, when the familiar patterns break down or the stakes are high, System 1 often hands the reins to its slower counterpart, System 2. Yet, because System 1's judgments feel so immediate and convincing, people may not always recognize when they have leapt to conclusions on shaky ground. For all its limitations, System 1 remains an indispensable ally. It allows people to navigate the complexity of modern life without being paralyzed by indecision. It frees up mental resources for more demanding tasks, enabling the mind to focus where it matters most. By handling the routine, the repetitive, and the immediate, System 1 grants the luxury of reflection and reason when there is time for them. In the intricate dance of decision-making, System 1 is the ever-present partner, spinning out judgments with astonishing speed and subtlety. Its strengths are evident in the smooth flow of daily life, its weaknesses exposed in moments of surprise or uncertainty. Understanding its workings, how it uses heuristics, how it shapes habits and loyalties, how it can lead both to creative insight and to bias, offers a glimpse into the hidden machinery of the mind. The more we learn to recognize the voice of System 1, the better equipped we are to decide when to trust our instincts and when to pause, reflect, and call upon the slower wisdom of conscious thought. Imagine yourself confronted with a tricky logic puzzle, a tax form filled with unfamiliar terms, or the challenge of learning chess for the first time. In these moments, a different mental gear engages, one that feels slower, heavier, and undeniably effortful. This is the realm of System 2, the mind's deliberate analytical engine. Unlike the swift, automatic responses that guide most of our daily lives, System 2 is the methodical problem solver, the careful checker, and the planner who steps in when intuition alone is not enough. System 2, as scientists describe it, is central to conscious thought. It is what you call upon when a task demands logic, reasoning, or the careful unraveling of a problem that cannot be solved by habit or gut feeling. When you work through a tough math equation, analyze a new set of rules, or weigh the pros and cons of a complex decision, you are experiencing System 2 in action. This kind of thinking is not just about numbers or logic puzzles, it is the mental space where abstract thought flourishes. System 2 allows us to imagine future scenarios, entertain hypothetical situations, and plan for contingencies, drawing on our capacity for hypothetical reasoning and future planning. One of the clearest illustrations of System 2's unique role comes from research using the Cognitive Reflection Test, or CRT. This test presents questions that seem deceptively simple, but are designed to lure you into a hasty, intuitive error, a response from System 1. To answer correctly, you must pause, catch the mistake, and override your initial impulse with controlled, reflective thought. In studies with medical students, for example, researchers have found that while many default to quick, intuitive answers, those who engage their analytical faculties more often, consciously switching from System 1 to System 2, perform better on these tricky problems. The CRT, then, is more than a test of intelligence. It measures our ability to recognize when our first answer might be wrong and to summon the willpower for deeper analysis. But System 2 is not only about getting the right answers on tests, its strength lies in adaptability. Unlike the rapid-fire judgments of System 1, which draw on learned patterns and emotional cues, System 2 thinking is flexible. It can override automatic reactions, reassess assumptions, and adapt to new rules or changing circumstances. When faced with a novel problem or a situation where the stakes are high, System 2 steps up. It is the mode we rely on for complex calculations, logical reasoning, and careful decision-making. Whether we are learning a new skill, making a major life choice, or navigating unfamiliar territory. In peak performance settings such as high-level sports or competitive academics, System 2 plays a crucial role. Athletes and professionals who excel often do so not just because of their intuitive expertise, their well-trained System 1, but because they know when to slow down, analyze, and make deliberate adjustments. System 2 allows for methodical error checking, troubleshooting, and innovation. It enables a chess player to plan several moves ahead, a surgeon to reevaluate a diagnosis mid-operation, or a scientist to scrutinize unexpected results. In these moments, intuition alone is not enough. It is the capacity for sustained, focused, and reflective thinking that makes all the difference. Yet for all its power, System 2 comes with sharp limitations. It is mentally taxing and easily fatigued, requiring sustained attention and effort. Most people find that after a period of intense analytical work, their ability to concentrate fades. This is not just a feeling, it reflects the real, limited capacity of System 2. Unlike System 1, which can process a vast array of information simultaneously and automatically, System 2 can juggle only a few pieces of information at a time. When you try to hold a long list of numbers in your head or reason through a complicated argument, you quickly reach the boundaries of your mental workspace. This workspace is often likened to working memory, a kind of mental scratchpad that lets us chain together different ideas, steps, or subproblems. Some researchers argue that what we call System 2 is essentially System 1, but augmented by working memory. In this view, System 2 is not a separate entity, but rather a process that links together the outputs of various intuitive subagents, enabling us to build complex, multi-step solutions. Yet the terminology remains a matter of academic debate. What is clear, however, is that System 2's power comes from its ability to assemble and manipulate information in ways that go far beyond the reach of automatic processes. Despite its sophistication, System 2 is not infallible. In fact, it is sometimes described as a lazy controller. While it has the capacity to monitor the quality of our mental operations and behavior, it often does so only when prompted. Most of the time, System 2 sits in the background, intervening only when an obvious error or challenge arises. It can check the answers provided by System 1, but unless something triggers its involvement, an inconsistency, a surprising result, or a high-stakes situation, it may allow intuitive errors to pass unchecked. This tendency toward cognitive laziness is not necessarily a flaw. It is a strategy for conserving mental energy. ensuring that the demanding resources of System 2 are used only when truly needed. Consider, for instance, the process of double-checking a calculation. If you quickly estimate the total cost of your groceries and the number seems off, System 2 may step in, prompting you to carefully recalculate with paper and pencil. This kind of methodical review is effortful and slow, but it is essential when the consequences of a mistake are significant. Similarly, when faced with a complex ethical dilemma, System 2 allows you to weigh competing values, anticipate long-term outcomes, and reason through possible courses of action, activities that would overwhelm the automatic processes of System 1. Learning and skill acquisition also depend heavily on System 2. When mastering a new language, for example, the early stages are marked by conscious, effortful attention to grammar, vocabulary, and pronunciation. Only with practice does the knowledge become so ingrained that System 1 can take over, allowing for fluent, automatic conversation. This pattern is echoed in countless domains, from playing an instrument to driving a car. System 2 lays the groundwork through sustained, deliberate practice, paving the way for automatic expertise. Yet, as powerful as System 2 can be, it is also fragile. Under stress, fatigue, or distraction, its resources dwindle, and we revert more easily to the shortcuts of System 1. This vulnerability is part of why so many errors and biases persist even in well-trained professionals. The analytical, logical route requires not just ability, but also the motivation and energy to persist through complexity and challenge. Ultimately, the interplay between System 1 and System 2 shapes nearly every judgment and choice we make. System 2 is not a constant overseer, rather, it is a resource-intensive backup, ready to intervene when intuition falters or when the stakes demand a higher level of scrutiny. Its strengths, abstract reasoning, hypothetical thinking, adaptability, and careful analysis, are counterbalanced by its slowness, limited capacity, and tendency toward cognitive laziness. By understanding when and how to engage System 2, and by recognizing its limits as well as its capabilities, we gain a deeper appreciation for the dynamic architecture of the human mind. The challenge lies not only in cultivating our analytical powers, but in knowing when to summon them and when to trust the speedy wisdom of experience. When we peer into the intricate dance between System 1 and System 2, we discover a relationship far more nuanced than a simple handoff between intuition and reason. The real world rarely presents problems neatly sorted for one system or the other. Instead, our minds draw on both, blending their strengths and weaknesses, sometimes in harmony, sometimes in friction. This interplay shapes our decisions, our problem-solving, and our vulnerability to error, whether we are navigating the complexities of scientific research or the unpredictable terrain of daily life. A persistent misconception in the popular understanding of dual process theory is the idea of a strict dichotomy, an either-or contest where System 1's gut reactions must always be checked or corrected by the steady hand of System 2. Yet, as critics of this so-called false dilemma have pointed out, most real-world decisions do not unfold as a relay race, with one system passing the baton to the other. Instead, evidence suggests that intuition and deliberate reasoning frequently overlap, inform, and even depend on each other. Intuitive responses, those quick, effortless judgments often associated with System 1, are not inherently flawed or irrational. On the contrary, in domains where a person has deep expertise, intuition can be remarkably accurate. An experienced firefighter, for instance, might sense danger in a situation without being able to articulate why, drawing on a vast reservoir of tacit knowledge. In such cases, the intuitive leap is grounded in years of pattern recognition, not in haphazard guesswork. The practical implication of this insight is profound. Knowing when to trust one's intuition and when to summon deliberate analysis is itself a skill. Research underscores that System 2 is best reserved for moments when biases threaten to derail our thinking, or when we confront unfamiliar, complex, or high-stakes problems. However, there are also many situations where System 1's swift, automatic processes should be allowed to operate unimpeded. Consider skilled physical movement, such as playing a musical instrument, performing surgery, or driving a familiar route, where conscious interference can actually disrupt performance rather than improve it. The challenge lies in recognizing which system best suits the task at hand and in developing the metacognitive awareness to switch modes appropriately. It is also a myth that System 1 is always biased while System 2 is reliably rational. Both systems are susceptible to their own forms of error. Intuition can mislead, especially outside one's field of expertise or when faced with misleading cues. But System 2 is not infallible either. Analytic reasoning can be hijacked by motivated thinking, limited by working memory, or simply exhausted by the demands of sustained attention. For example, a scientist who relies solely on analytical rigor may overlook creative solutions that emerge from intuitive insight, while someone who trusts only in gut feeling may miss critical evidence that contradicts their initial impression. The complexity of their interaction means that neither system guarantees accuracy on its own. Effective problem solving often requires a back-and-forth dialogue between fast and slow thinking. This dynamic is especially apparent in high-pressure environments. In crisis management, for example, stress can push individuals toward automatic, intuitive responses, sometimes beneficial when rapid action is needed, but sometimes detrimental if those instincts are shaped by fear or bias rather than expertise. Recognizing the limitations of both systems can help individuals and organizations design better decision-making strategies. For instance, training that simulates high-stress conditions can help professionals build reliable, intuitive responses, while protocols that prompt a pause for reflection can guard against impulsive mistakes. The practical lesson is not to idolize slow, rational thinking at all costs, but to cultivate flexibility, knowing when to act on instinct and when to step back for a more deliberate assessment. It is equally important to dispel the notion that rational, analytical thought is always the ideal. Research suggests that in many familiar or time-pressured situations, intuitive processes are not just efficient, they are adaptive. For example, a chess grandmaster can often spot the best move in a complicated position within seconds, drawing on patterns internalized through years of practice. Here, the distinction between intuition and analysis becomes blurred. What appears as a sudden insight is actually the product of deep, structured experience. In such cases, forcing the mind into a methodical, step-by-step analysis can actually hinder performance, creating doubt where there should be confidence. On the other hand, the same reliance on intuition can become a liability in novel or ambiguous situations. When the cues that normally guide System 1 are absent or misleading, the mind's tendency to leap to conclusions can lead to significant errors. This is why deliberate reasoning is so crucial in scientific problem solving, where the unfamiliar and the counterintuitive are commonplace. Yet, even here, intuition has a role to play, generating hypotheses, spotting anomalies, and inspiring creative leaps that pure logic might never reach. The most effective thinkers are those who can move fluidly between systems, drawing on the strengths of each. The interplay between System 1 and System 2 also has implications for how we structure our environments and routines. Simple changes, such as introducing checklists, prompts, or reminders, can help nudge the mind from automatic to reflective mode when accuracy is paramount. Conversely, designing tasks to become more routine and familiar can shift the burden from slow, effortful thought to fast, automatic performance, freeing up cognitive resources for new challenges. In both science and everyday life, the goal is not to eliminate one system in favor of the other, but to engineer conditions where each can shine. Underlying all these insights is a recognition that the architecture of human cognition is more tangled than any model can suggest. The boundaries between fast and slow thinking are porous, and the mind's ability to blend intuition with analysis is what gives human judgment its remarkable flexibility and its enduring fallibility. Both systems are necessary, both have their blind spots, and both are shaped by experience, emotion, and context. The task for individuals, teams, and societies is to cultivate an awareness of these dynamics, to design processes that minimize error, and to foster environments where the best of both systems can emerge. As we close this journey through the science of thinking, it becomes clear that the real power of Kahneman's model lies not in dividing the mind into neat compartments, but in revealing the subtle, ongoing negotiation between two ways of knowing. In that negotiation, there is no substitute for self-awareness, no shortcut past the hard work of learning when to trust the gut and when to engage the mind's full analytical firepower. It is in the tension and, at times, the harmony between intuition and reason that we find our greatest strengths, our most persistent errors, and our deepest opportunities for growth.